Good morning, President.
Good morning, sir. Namaskar, sir.
Namaskar.
Sir, what? Yeah, namaskar.
Good morning, Chairman.
Yes, sir. Good morning, sir. Sir, good morning, sir. President, sir, good morning, sir.
President, sir. President, sir. President, he could not.
Arsha, please make co-host. Yeah. Yes, sir. Now you become co-host, sir. President, sir, please speak out, sir.
Yes, good morning.
Yes, sir. Sir, good morning, sir.
Good morning,
Namaste.
sir.
Morning, namaste, namaste, namaste. India Namaste has become very popular during COVID times.
Sir.
Recognized worldwide.
Yes, sir. Sir, Dr. C.H. Hanumantrao is there, sir, our head of the department.
Right, right. Good morning, Professor Humantrao.
Good morning, sir.
Morning. Mr. Suresh, good morning. I could
Morning,
hear
sir.
you, but I couldn't speak to you. I just thought let me join a few minutes earlier. It's always better to meet people before the formal program begins.
Sir, your voice is not audible, sir. Hanumantrao, sir.
Am I adequately audible, Mr. Pararaju?
Yes,
Yes, sir. You are audible,
Okay.
sir.
Okay,
Very clear.
very good. Very good. Thank you.
What about mine?
Yes, sir.
It's
Your
okay.
voice is also clear, sir.
Mr. Suresh, you're more than
Yes,
heard
sir.
in South, I know.
Something. There's always this network problem will be there.
Hmm.
Our Vijayawada Center Chairman has done a wonderful things.
Yes.
Really, it's quite appreciated.
How far is this Guntur from Vijayawada, or is it very close?
25 kilometers. 25 kilometers.
All right, very close. Is it a regular? Yeah, I can see it's a third international conference. So is it a roving kind in different countries, or is it normally held in India?
In India, sir, in KLU only, we are taken this theme.
Okay.
In the year of 2011, we have conducted first series, sir. Later on, there was a goose gap. Again, 2019, I have undertaken and I have conducted the second international series,
Right.
and now it is the third one.
Right.
Yes. Yes, you can begin, Hamim.
Well, sir, certainly. Very well. Good morning, all of you. Respected dignitaries, chairs, conveners, organizing secretaries, guest of honors, and my dear fellow participants, to all the academic community. Myself, this is Dr. Hamim Syed, working as Assistant Professor, Department of Civil Engineering. It is my pleasure to welcome you all for the third International Conference on Advances in Civil Engineering, organized by Department of Civil Engineering, KL deemed to be University. I thank everyone for joining with us today. I would like to give a little housekeeping before we get started. These 2 days will be dedicated to cover a wide spectrum of themes related to advances in civil engineering. The conference tackles important topics on civil engineering and its elite fields. I am sure that each one of you will identify subjects of your interest and will benefit from many fruitful and enriching discussions. It is for me a great opportunity to act as a host for this inaugural session. And without further ado, let us begin with a prayer song.
स्मरामि महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दितमहागणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दितमहागणपतिम्
Well, thank you so much. With this warm begin, I would like to call upon one of our conference chairs, Dr. G. Apparov Garu, Professor, Department of Civil Engineering, IIT Madras. He has been one of the main proponents of this conference for the several years, and it is a true standout in this field. He has a great understanding of and a great appreciation of what it takes to truly make the conference continue on a path of progress and a remarkable vision. With this, I welcome Dr. G. Apparov Garu, Professor, Department of Civil Engineering, IIT Madras, and I request him to take over and speak a few words about this conference. Sir, you may take it now.
Yeah, very good morning, and welcome the dignitaries on the dais, of course, online, and the participants and the authors and the invited keynote speakers. It's my pleasure to be here and to involve in this conference. So the hard work by the head of the department and Professor Paul Razu and all young faculty members, the Department of Civil Engineering, Keele University. In fact, the contribution by the young faculty, it is something outstanding. A very short time planning this conference and coming out with a very a kind of magnitude involving a lot of administrative things and also financial. Without financial support, not easy. And of course, more than that, the technical contribution from people and the expertise from various parts of the world. I think it is our honor and the university. So we respect you all and in welcoming for this 2 days event. I congratulate the head of the department and Professor Paul Razu for their efforts. Continuously, they have been striving to improve the quality. And of course, several hundreds of papers have been received abstract. and shortlisting them and coming out with something like a good standard. It is not easy to plan and organize such conferences. So it is the hard work by the Department of Civil Engineering, KL University. Of course, it's my privilege to involve in these activities. So it is academic collaboration with people in the country. Of course, maybe special affinity towards KL University. As Dr. Paul Raj is my student, so he worked with me at IIT Madras for PhD. So it is wonderful collaboration, and of course, many more years will continue this way. And I hope the Department of Civil Engineering will have such more programs in the future years to come. And the participants, and this is a great venue for you to interact with experts and gain knowledge. And I hope you try to utilize the resources technically. And you should also, again, understand how to plan these things. And you should grow. When you grow, then your institute will grow, and your location, then as a whole, the country. So all these programs will reflect the activities of civil engineering, of course, structural engineering, of course, I'm related to that. I hope the next 2 days will be fruitful to the participant, and I wish the conference be a grand success. I wish the participants also all the best. Thank you, and welcome you again. Thank you very much.
Thank you so much, Dr. G. Apparov, sir, for your warm words. Now I request our convener, Dr. C.H. Hanumantarao Garu, who is also the head of the Department of Civil Engineering, KL Dream to be University, to give welcome address about this conference.
Sir, there is some technical issue with Hanumantarao, sir, I think so. Sir, voice is not audible.
Yeah, it seems so. Well, anyways, Hanumantarao sir would like to connect whenever he would be able to. So with your permission, dear convener, so I would like to move ahead with the program. So I would like to call upon our guest of honor and Principal College of Engineering, Dr. K. Subbarao sir, to speak his remarkable words and boost us towards success of this conference. Subbarao sir, you may kindly take over and speak a few words.
Very good morning to one and all. Chief guest, Sri Vinay Gupta, President ICA. Guest of honor, Sri S. Suresh, Vice President, South ICA. Conference chairs, Dr. G. Venkatapparao, sir, Dr. G. Apparao from IIT Chennai, and Dr. G. Venkatapparao, sir, former professor of HOD IIT Delhi. All the participants, dignitaries, I welcome you all once again. I'm very happy in associating myself with the Department of Civil Engineering on the inaugural function of this third international conference on advances in civil engineering. This university, as a small engineering college, we started in the academic year 1980-81. Now, this is one of the very few universities with NAC A++ accreditation, and also this has got the remarkable achievement of placing 100% students in reputed companies in all the departments for the past 16 consecutive years. Our vision is to be a globally renowned university. All our programs in this university, they are in accordance with taking this university to a world-class university. In this university, irrespective of the department, every student will be trained with equal emphasis in academics, overall personality development, excellent industry institute interaction with which the student will be made ready to the needs of the industry, involving students in various research activities, embedding skilling component in the curriculum itself, and refining those skills periodically so that the student will be ready-made to the needs of the industry. A lot of care is being taken by the university with respect to making the students entrepreneurs also. I appreciate efforts of conveners, Dr. C.H. Hanumantarao, who is also the head of the department, and also Dr. Paul Razu, who is another convener for this conference. I extend my sincere thanks for the wonderful support that is given by the conference chairs, Dr. G. Venkatappa and also Dr. G. Apparao, for their valuable support to the Civil Engineering Department for organizing this two-day conference. I appreciate efforts of every faculty member of the department for bringing this international conference live in very short span. And also in this pandemic situation, though this is a pandemic situation, in one way, this virtual international conference is helping many participants across the globe to connect and participate in this situation. I wish this two-day program a grand success. My sincere thanks to the management, Honorable President Sri Koner Satyanarayana Garu, for continuous support to every department of this university for conducting such wonderful events in their departments. I extend my sincere thanks to Honorable Chancellor Sri S.S. Mantagaru, Pro Vice Chancellor Dr. Venkatram, and my colleagues, Dean Skill Development, Dr. Srinath, Dean R&D, Dr. Jaykumar Singh, for their continuous support to the department. I thank the organizers for giving the opportunity to me for associating myself in this inaugural section. Thank you, one and all.
Thank you so much, sir. Thank you so much, Subbaro, sir. It is always very pleasant to hear from you and have an inaugural session to have your inaugural address. In fact, in an event. Thank you so much, sir. Thanks a lot for your time and your presence. So now I would like to request our convener and head of the department, Dr. C.H. Hanumantrao Garu, to give welcome address about this conference.
Thank you, Dr. Hanuman. Hope at least now I am audible.
Yes, sir. You are audible.
Yeah. Thank you.
Yes, sir.
First of all, I must be very thankful to our honorable management, our honorable president, Engineer Sri Koner Satyanarayan Garu, and the vice presidents, Engineer Havish Garu and Rajaharin Garu, and our honorable chancellor, Professor S.S. Manta Garu, pro vice chancellor, Professor N. Venkatram Garu, our registrar Garu, YVSSV Prasad Garu, our honorable principal, Dr. K. Subbarao Garu, Dean Skill Development, Dr. A. Srinath Garu, and Dean R&D, Dr. J. Kumar Singh Garu, who approved to conduct this two-day online virtual conference on third international conference on advances in civil engineering today and tomorrow. And I must be very thankful to both the conference chairs, Professor G. Venkatapara Garu, who is the conference chair for the first international conference, and Professor G. Appara Garu, who is the conference chair for the second international conference. And now both of them have guided us in making this conference in a wonderful way. I also thank the today's chief guest, Engineer Vinay Gupta Garu, President ICA, and also Engineer Suresh Garu, Vice President Southern Region, and also ICI for allowing us to take their support, ICI, for this conference. We are very thankful to ICI and also IGS and ACCE India and CEA. These are the student chapters which we are having. All these 4 student chapters in our department are very active. These student chapters have taken initiation and taken the lead in organizing 4 special tracks, one in structural engineering, one in construction technology and management and construction materials. The third one is geotechnical and transportation engineering. Fourth one is environmental and water resources engineering and GIS. So like that, except inaugural function and the keynote, inaugural address by Engineer Vinay Gupta Garu, remaining all 36 keynote speakers across the globe. We have identified senior most academic researchers to youngest researchers as keynote speakers we have taken, such that these 2 days, these 36 plus inaugural 37 keynote speakers are going to deliver each for 45 minutes. That's how huge amount of knowledge, latest recent trends, what exactly is happening in all specializations of civil engineering is going to be shared on this platform. And we have received 240 papers. Out of 240 papers, finally, we accepted around 135 papers, which are going to present in these 2 days in 4 parallel sessions. I also thank IOP Journal, which is a Scopus and SCI indexed journal, who is accepted to publish our accepted papers with our editorial. All these 135 papers are going to be published in the journal. If any of this 135 paper, if or not really meet the expectations of the quality of the journal, then we already got ISBN number also. So the souvenir with all the abstracts and also with the public papers which were not up to the mark of the journal are going to be published as conference proceedings. If all the quality papers are going to be published in the IOP conference series journal, which is both SCI and Scopus indexed. That's how this today international conference, we got 9 international keynote speakers and 27 national level keynote speakers with all kinds of international papers as well as the national, and the representation of all the states. It's blended perfectly, and I hope every participant will enjoy and learn all the recent trends in their respective domains. I hope this conference will be very successful. Though this conference was started almost 9 months back, due to this pandemic, we want our faculty want this conference physically to be happen. That is the reason why we tried our best. We waited to this pandemic to be completed, and so that we can organize this conference physically at our campus. But since there was no hopes of when it is going to be completed and how we will be able to meet physically when it's going to happen, by keeping all that, finally we decided to go completely virtual. And I also must be thankful to my co-convener, Dr. P. Paulraj Garu, though he went on leave to VR Siddhartha. Earlier he was the HOD, and he organized the second international conference as convener under the guidance of Dr. G. Apparao Garu. And again he was back, and immediately we made him as a co-convener for this and hand over to him. And Dr. Sanjit Kumar and Dr. Virendra Kumar Khed and Dr. Ashwin Raut. These are our 3 associate professors who are the organizing secretaries who made all this planning very efficiently and organized with the help of the entire organizing committee of our all faculty of my department. Meticulously they planned, and everyone, they tried this Google YouTube streaming or this WebEx links they tried, and all the keynote speakers, they have meticulously followed. They got their photographs, brief profile, edited the profiles, and got the papers and sent to the reviewers outside, and brought their comments and again sent to the others, and finally they made everything possible. So I thank the entire organizing committee of my department. I thank all my faculty and research scholars. 4 research scholars, full-time research scholars are there with us. All the 4 full-time research scholars, they made editing of all these papers into the conference journal format, and I must be thankful to all 4 of them. And also the technical board who helped us in reviewing the papers. This all 240 papers we sent to the 2 reviewers external, and they are very cooperative and they send the comments very quickly. And I must be very thankful to all of them. And also the National and International Advisory Committee also helped us a lot. And I hope this 2-day conference will be a grand success. Thank you. Thank you all for your kind.
Thank you so much, Hanumantrao sir, for giving a overall overview of this conference. Once again, it is a great pleasure for me to call upon our guest of honor, Vice President Engineers S. Suresh Garu, South Zone, ICI, to give his opening speech. Sir, you may now take over. Sir, sorry, you are not audible. You may unmute, sir.
Good morning to one and all. Respected Chief Guest, Engineer Vinay Gupta sir, the President, Indian Concrete Institute, Honorable President, LEF, KLF, Vice Presidents, and all dignitaries of KL deemed to be university, and patrons, conference chairs, conveners, delegates, invited guests, and academicians from various apex institutions in India and worldwide. It gives me great pleasure and pride to be the guest of honor for the virtual inaugural function of ICACE 2021, the 3rd International Conference on Advances in Civil Engineering. I thank the management of KL deemed to be university and the Department of Civil Engineering of this institute for having arranged these international conferences in association with Indian Concrete Association, Association of Consulting Civil Engineers, India, IGS. I take this opportunity to appreciate the chairman of Indian Concrete Institute of Vijayawada Center, Dr. P. Paulraju, for taking the initiative, and I could feel his tireless effort and passion for conducting this program. From the flyers and records furnished to me, it is obvious that the entire program has been planned meticulously, involving 36 stalwart speakers from various institutions and creating a platform for brainstorming on various topics from structural engineering, environment, construction materials and management, water resources engineering, and geotechnical and transportation engineering. It seems to be a concise skill development and awareness program of 4 sessions. The 36 collaborative speakers collectively around the global bring in an expertise of centuries. Really, they are going to bring in an expertise of centuries of expertise, which is an encyclopedia of knowledge, which could be referred by every individual attending these 4 sessions. We have 35 youthful, energetic, knowledgeable researchers presenting their hard work in various disciplines of our engineering profession. Each one of them would have to drive home these research findings in a short span of 10 minutes, making it a Herculean task of precisely writing their papers, which has taken months or years of fact findings. My request to the students, delegates, is to grab the opportunity by participating and involving themselves in their topics of interest and engage themselves in all deliberations to make the purpose success. This August platform will be a stream of knowledge that we all could quench our thirst. Really, at the end of the day, everybody will be feeling that this August platform will be a stream of knowledge that we are all could quench our thirst. I am so happy to see that the main objective of our institution is achieved by the immense knowledge that is to be disseminated in the next couple of days. As a Vice President, I take this opportunity to say a few words about our Indian Concrete Institute also. The ICA administrative setup consists of President, 4 Vice Presidents, and 17 GC members. The genesis of ICA dates back to the year 1982. ICA is a strong professional body having more than 13,000 enrolled members from 42 regional centers by length and breadth of the country. There are more than 341 organizational members and nearly about 300 student chapters. Our icon programs are the Innovative World of Concrete and ACCon. The ACCon will occur in every 5 years, and this time it is proposed to have it at Delhi in 2021. I request all the participants and delegates to attend this program and register themselves and attend this program. I welcome you all. Apart from this, there is a technical committee involved in release of many a number of technical handbooks. Moreover, we have MOU signed with Asian Concrete Federation, which is a cluster of 9 Asian countries: Singapore Concrete Institute, Australian Concrete Institute, Korean Concrete Institute, American Concrete Institute, and RILAM, for exchange of technical documents and to organize programs like this and international programs. I thank you once again. May we bash in the brilliance of these August gatherings. Yes, we are going to bash in the brilliance of these August gatherings of expertise speakers. All the very best for the success of this program. Thank you, one and all, and wish you all the best. Thank you.
Thank you so much, Suresh sir. It's been a pleasure to have a huge knowledge on the ICI, as well as you have briefed about the conference and the proceedings, and you have congratulated all the participants. It's been so nice of you. Thank you so much, sir.
Thank you.
Finally, here comes time to listen from the person I have been waiting from a long time, the chief guest, Engineer Vinay Gupta, President, Indian Concrete Institute. Sir, you may begin your inaugural address, followed by the release of souvenir after your auspicious talk. Thank you, sir.
Thank
so
you.
may
Thank
now
you,
take over.
Professor.
Thanks a lot.
Thank you, Professor. Just tell me if I'm audible once again, because sometimes it gets muted.
You are audible, sir.
Thank
Yes,
you. Thank
are
you. Thank
audible,
you.
and it's perfectly fine. Thank you.
All right. So good morning, everybody. All those who are from eastern side and India, and perhaps some of the far from the western side. Of course, it's good morning anyway to you. I wish you a very good morning, and maybe good afternoon to some who may be in Australia or far off places. It's very heartening for me to see that this college, KL University, and Department of Civil Engineering has taken up such a gigantic task of organizing this international event, and third time in a row. I was told the first event took place, event of this ICACE in 2011, and whatever it was once again held in 2019, and now it's in 21. And I'm sure in times to come, I request you people, the organizers, to please make it regular, maybe once every alternate year, or once every fourth year, or every year, or whatever you like. Let there be some regularity, but I'm glad to hear that you have continued with the trend and not stopped it, not given up. So that's a very good thing to hear about. My thanks to Dr. G. Venkata Rao, Dr. G. Apparao, Dr. P. Poluraju, of course, I'm quite associated with him very closely, Dr. Hanumantha Rao, and of course the entire team who's been working behind organizing this event, and all the faculty of KLU and other colleges. It is very interesting to hear, in fact, very encouraging to hear that the placement of this university has mostly been 100%. That shows the success of the hard efforts that the faculty puts in, that the students put in. So that's very good. Of course, we are all coping up with this pandemic, COVID-19, but I'm sure we are also getting enough time to rejuvenate ourselves, and we should continue doing it. Especially, I know that there are several students in this forum, so my few words that I always like to say to the students, friends, as civil engineers, normally we say that the engineers have a low self-esteem. They try to be not too much heard because they think as if, they have not done very great job by being engineers. But if you look at it, the engineer builds a world in my recommendation. The civil engineer builds the foundation of this world. Mechanical engineer puts a system into this world, or in the building or factory or whatever. The chemical engineer puts a flow into the system. Electrical engineer puts energy into the system, and the computer engineer puts a program for everything to start functioning in the system. So when so many things are done by the engineers, then why do we think that we are not as reputed as other disciplines? Say doctors, chartered accountants, and so on and so forth. In fact, if you look at the other side of it, although I'm not against the doctors in any case, but the documents or recordings are doctored for malified intents. Whereas anything is engineered for good. So engineers have a pride. And therefore, we should call ourselves engineer so and so. Of course, if we are a doctor, research holder and all that, fine, doctor is good. But otherwise, more than even Mr. or Miss or Miss, I'll rather say we are engineer so and so, and take pride in saying that. As college, I would like to suggest, recommend, from my experience, that industry academia interaction is very important. is very useful, because when a person is doing a lot of deep down theories in college, he must also know where it's going to be used and what modifications he need to make, in which directions he should think or she should think to the industry. Because finally he has to get into the industry, start designing it, constructing it, and practicing it. We have gone to the era of digital technologies, drones for inspections, and very recently I have prepared a document wherein I have recommended, and is going to be published by NHAI for all over the country, is to use CCTV cameras at all the construction locations and keep recordings for at least 3 months. You hear of a lot of examples where the structures have fallen during construction, and then we try to make guesses as to why it happened. Why make guesses? Have a CCTV, you'll know what the reason was. Then the correction in future is easier. So that's one thing that I brought into the document. I thought I must tell you. Any structural design that we do, it must be constructible. Not only constructible, it should be safe at all the construction stages. And not only in service, but also during construction stages, it must be safe. Anyway, I have gone through some parts of this conference over the last few weeks, and I find that this conference covers a panoramic gambit of all civil engineering aspects, which is something commendable to talk about. So I would rather like to wish this mega global event a grand success. And of course, I'll begin with my presentation now. Let me see how to share the presentation. How do we share? My share icon is disabled. So can
Yeah, so
somebody
you
help
will
me,
be
please?
given access. You will be given access.
Yes.
Sir. Just a second.
Please, please. And I will see if I'm doing first time on this platform, Cisco WebEx, whether I can share directly or I have to do something else. Let me try. Yes, I think it seems to be coming.
Yes.
Okay.
So we can see your presentation, sir.
Oh, okay, very good. I'll put it on the slideshow. Yes. Do you see the whole screen now?
It's perfect. Yes,
okay,
sir. It is.
okay.
It is
Great,
visible.
great
Thank
to
you.
see that. So friends, the topic that I have chosen, this is, technologies for aesthetic. We all like aesthetics, durable and sustainable construction. I've very carefully chosen this topic. Aesthetics are for the present day world that people like. People like you and me, we want iPhones, we want large phones, or we want aesthetics, beauty. Durable and sustainable is important because I found that in UK, at least Indian figures may not be available. In UK, till about 20 years ago, I know very well, I don't know what has happened after that, a major part of their annual budget for the construction, something like half of it, used to be spent on repairs and rehabilitations and retrofitting of the structures, especially bridges. Imagine if that was not done, if that was not necessary, we would have had 50% more infrastructure with us. But we can't, because we have to spend that budget into something else. So durability, sustainability is extremely important. Durability, of course, is one that we discussed. Sustainability from the point of view of the materials, from the point of view of our resources that we have, and so on. So that is the reason I've chosen this topic. And especially the students are stepping into the next era of the world. So they must realize the importance of this thing. Now let me try to get it to a presenter pointer option, which will be laser pointer. Okay, right. Okay. So in case I overshoot my time, please stop me. I'll try to maintain by 10:30. All right.
All right.
So the aspects,
problem.
thank you so much. So the aspects majorly that we have to look at when we talk of technologies, aesthetics in the urban and landscape, where we have a structure in the urban area. Reduced traffic disturbance during construction is very important nowadays. Speedy construction is all we think when we talk of computers. We always think of speed. Reduced carbon footprint. This is something which is another aspect which everybody has to learn, that look, I should not be oozing out too much of carbon dioxide or carbon monoxide, because they will lead to greenhouse effects, which have their own detrimental effects. We all know about it. And for that purpose, we use blended cements, fly ash, ground granulated blast furnace slag, microsilica for some purposes, galvanized or stainless steel reinforcement, and reduced side produced concrete so that the air pollution is reduced and the speed goes up anyway with the precast. So talking of the aesthetics, look at this interesting picture which I visited this place in Montreal in 2001, I think. Each of these building blocks that you see, they are precast blocks constructed elsewhere, brought to the site and erected in place and connected. So that is how Moshe Saadi, the American architect, conceptualized and received several awards for this concept. Look at this picture. It looks like a toy, as if your child is playing with this. But when you look at the people moving around, you find that no, it's not a toy, it's a building. Who designed? Structural engineers. Who constructed? Structural engineers. Who conceptualized? Maybe architects. So it's the same lobby. Like in this case, the architect is Frank Gehry. Bilbao, Spain, museum in Spain is a very famous museum among architects. And I'm sure some of you who are from Spain would be knowing about it. Look at this marvelous structure in India itself. What you see on the left, I think, is the famous stock exchange building in Mumbai. What you see on the right, it is Bangalore Infosys parking constructed by L&T, which was awarded by ICI some time back for the best precast concrete building. All the facade that you see is a precast concrete facade manufactured and raised to the location. Look at this simple architecture. Somebody has designed an arch in concrete, in steel, whatever it is. All he has done is just tilted the two arch ribs close to each other so that they are not parallel, rather they are at a changing angle, which adds to the beauty. So engineers can think in these directions also, unlike architects. Well, not unlike, like architects, sorry. All right, so now we talk of cable supported bridges. We all know cable stayed, cable stayed, cable stayed. How many types are available in cable stayed? It's not cable stayed, I would say cable supported. Cable supported has one category, that is a suspension bridge, where you have one long main cable and you have auxiliary cable supporting the structure. Other category that came later after that is cable stayed bridge, wherein you have a tall pylon and you have several cables supporting the structure in their own style. And third is extra dosed bridge. That's another category which has recently come up, but it's become very popular, especially in India. There are a large number of extra dose bridges. Something like, I would say, 40-50 extra dose bridges must be there in India, and something like 25 to 30 are cable stayed bridges and very few are suspension bridges. When you talk of any structure as a structural engineer, you would say my pylon should be at the middle and I should have a balance of left and right. That means have equal structure on the right side of it, equal structure on left side of it for it to be balanced out. That's how an architect, a structural engineer would think. And you have been doing it for ages like this. But when you give the same problem to an architect, he says, no, 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 I don't like it. Please make it something which is difficult for you. So he tells you that, look, Mr. Structural Engineer, please give me the pylon on one side and all the balance structure on the other side. So what was done by this world famous architect Santiago Calatrava, who is a structural engineer turned architect, mind you, from Spain. He designed this bridge wherein the pylon is made in concrete, inclined at 32 degrees to the vertical, and the 200-meter span of the structure, the deck, is in steel, and balancing act is done by inclining the pylon, making it heavy, thus concrete, so that finally you see something which is different from most other cable stayed bridges. Now you give the same problem to another architect and say, look, I have a span which is about 200 or 284 in this case. How do you like Santiago Calatrava's design? He said, no, 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 I don't like it. Not very good. how do you incline the pylon? It's so difficult to construct and I don't like it. I'll make something different. So what this world famous architect Ben van Berkel does, he's a German architect, Dutch architect. He makes a pylon vertical. He puts a bridge on one side, as we do, but all he does is to stabilize a pylon, he puts this kind of a backstay connected to the ground where there's rock through rock anchors to take the reaction. And to reduce the weight of the superstructure, the deck, they have not put normal wearing course, that is your this bitumen and all that. They have rather placed 8 millimeters thick polyurethane, that's it, which is very light, very thin. Of course, I visited this place about 20 years ago. So India said, why not? We have our famous terminology, namaste. The whole world has learned namaste now during COVID times, that you are not supposed to shake hands. So in India also we designed a signature bridge which is a namaste shape, and that's something like this. We have the structure of 251 meter span on the right hand side of the, well, I hope your right is right and not left. This side, we have a 251 meter span. We have a pylon here, and we have backstays which are just like this, anchor to a tension arrangement here, which is very interesting. In fact, today evening there's a lecture on this bridge at 4 o'clock, IE-Structi. So this is how the Namaste looks like when you see it from one side of it. And the approaches to this bridge are also very interesting. In fact, we are involved in the entire project, the approaches as well as the main bridge. Total cost must be in the range of about 1500 crore. Wherein we have very fancy looking sort of ribs attached to the box structure. And of course, mind you, since we have a lot of these high level technocrats here, let me tell you here, there are tension pendulum bearings. Tension pendulum bearings, the vertical tension of the bearings at the tension zone is 6,000 tons per bearing. And at this place, we have a spherical bearing with a 17,000 ton capacity each. Largest in the country so far, maybe worldwide, I'm not very certain. Because under the pylon, the loads are quite high. All right, so let's look at a building project, because you must be fed up of bridge, bridge, and bridge I've been talking about. This is a project, if somewhat a structure which is existing, people are visiting. It's a kind of a monument equivalent structure recently built by L&T, and we were the designers. Moshe Saadi, the American architect, was the architect. Here, the whole structure that you see, of course, it has its own beauty. Is 85 kilometers north of Chandigarh in Punjab itself. It's a heritage kind of a structure. The interesting thing is, this structure, to my knowledge, has a largest percentage of architectural fair faced or exposed concrete, so that the structural engineer is visible. Not that you put false ceiling throughout, and the structural engineer can maintain his low self-esteem and remain the same way. Here what they do, they play a very good trick. They expose all your concrete, make the concrete very good in quality, and in this case we put some 7% of blast furnace slag to give a particular color to the concrete that the architect wanted. And you see false ceiling, but you also see the beams. Another, in the same project, in the same structure, you run from one end to the other end, there is a 150-meter long pedestrian bridge, and you have some kind of a canopy, more for beauty than for real purpose. Everything is precast, precast, and precast. Precast concrete, I mean, not everything I would say, but most of this canopy is precast, and it's fair-faced concrete. So what they've done is that the architect has conceptualized is that all these beams that we see, they may be as deep as 600 mm. In between the beams, they will put a false ceiling, but they will expose 150 mm below, 6 inches below, so that you see the structure. That's a very good justice they've done to the structure. So like here also, if you see, there's an arch provided with a library on top. But the arch also, you can see every time something or the other is visible, which gives a good combination of the stone cladding that architects want, the structure that you want, and it's a combination that everybody wants. All right, come to a semi bridge project. There's a metro station. This is a picture from one metro station in Bangalore, where if you see all these beams at the concourse level is the one where you climb up to buy a ticket, then you go further up to the platform to pick your train. So this concourse level, all the beams that you see here are precast, pre-tensioned beams, and all of it is made in such a way that the traffic keeps running while the construction is on, which is important because nobody likes disturbance to their movement. Another very interesting masterpiece that we did about 17, 18 years ago in Delhi is we got a package of 6 stations to design, elevated, over the running roads, and mandate was my road traffic should not stop. So we made a more or less everything precast kind of a station. 6 numbers, of course. I'll just walk you through it. Here is a footpath. Here is a 11-meter wide road. Here is a median. I hope this pointer is visible. And here is the footpath again, 11-meter wide carriageway. And that's a 3-lane carriageway. So what happens is that you construct the pile and pile cap at all the 3 locations or 3 sets of locations. You construct the pier, which is in situ, in the median, in the footpath, left, right, everything. After that, more or less everything is precast and no disturbance to the traffic, neither at this stage nor later on. Disturbance, but least disturbance, let's call it. Now, is typically here station is 180 meter long. Why 180? Because it has to cater to 8 coaches. For 8 coaches, the length is 180 meter platform. So for that, such frames that you see here have been provided at every 15 meters as many numbers, 12 numbers or whatever it comes to, or 30 numbers. So what is done is that we have transversely precast post-tension girders, which are not fully visible, but they have a ledge. Longitudinally, we have precast pre-tensioned double T units. You have 2 verticals and a slab on top. Precast, pre-tension, double T. And of course, on top, we just put a screed or rather RCC topping, I would say. Here we have a pier crossset, kind of a pier cap, which is also precast post tension attached to the pier with the help of vertical pre-stressing. Here we have the track supporting precast pre-tension U-shaped girders, which you see at many places. And of course, in situ slab here. And we have platform, which is also made out of the structure similar to concourse that is below. And once a platform is built, we make the structural steel roof all on top. So try not to disturb the bottom. So this is a concourse level where we will be supporting transversely those 14 meter long precast post tension L beams, means beams of the ledges. This is that precast this cross girder or cross head, which is weighing 50 plus 100 tons, vertically pre-stressed for connection. There is no in situ reinforcement going up and all that. And these are the U-shaped track girders. Some pictures taken at night. Construction was, all this was done, lifting etc. at night, and only when you're doing a clear construction on top, that was permitted in the day. So traffic was reduced, the disturbance was reduced to minimum. Similarly. So just some more pictures only I'm showing. We call it L beam, call it a beam with a ledge to support the longitudinal precast pre-tension double T units. The roof construction, which is a kind of a PB, but not really a PB. It's only termed as PB. All right, date ourselves back about 32, 33 years ago, way back in 1987 and 88. We designed a factory for color picture tube manufacturing in Ghaziabad, North India. The factory is not having a steel shed as you normally think. It has a concrete roof and is still constructed in 11 months, way back in 1988, 1989, in 11 months for an area of 25,000 square meter. And when you construct it fast, it's an excellent commercial deal for the entrepreneur. He has to start his production very fast. So what is done is these 25 meter span precast post-tensioned concrete trusses manufactured on ground, lifted on top, placed on the piers with the elastomeric bearing sandwich. And the roof here is also built with the help of this precast RCC C-shaped, inverted C-shaped channels, something like this. So we have at every 10 meter we have a grid where we have pier, we have these trusses, and elastomeric bearing is here. Elastomeric bearing in that time we still used it for taking its effect on the time period of the structure and reducing the seismic force to nearly half. Because Delhi, Ghaziabad and all are seismic zone 4, which is high seismic zone. Okay, then came Commonwealth Games 2010. In Commonwealth Games, this 4 plus 4, 8 kilometers of viaduct was to be constructed to travel from Commonwealth Games residence venue to Jawaharlal Nehru Stadium, famous stadium. The time given was 20 months. End date was fixed. It could not be moved because from the end date, some 10 days or 15 days later were the Commonwealth Games in October 2010. So it was so constrained site that in 20 months, you had to construct how many? About 8 kilometers. That is 4 kilometers and another 4 kilometers up and down. So this was a typical site of the precast segmental construction, which you normally do. So I will not elaborate. There were several special crossings where large span structures had to be made. And the worst one was this. Of course, all these have a large span to the tune of central span of 84 meters. But the worst was this, which is the railway crossing near Nizamuddin in Delhi, wherein a cantilever construction unit had to be constructed. If you go for balanced cantilever construction cast in situ, it would take something like 6 months, and you don't have 6 months for the superstructure. Here, we had to do precast with a specially manufactured and supplied by NRS of Norway, a segment lifting frame, which can move with the segment from one end to the other end. You notice here? So that you can feed the segment from anywhere, bring it to the required location, put the pre-stressing. And there were also conditions where construction had to be done over the railways, which I discussed just now. So when you construct it over the railways, you have many of the safety aspects you have to exercise. Railways will not permit you to construct just like that. So for them, it's very important. And this is a railway line, which is the busiest line of the country, Delhi to Mumbai. So the block time that was given by the railway authorities, because construction over the railways is permitted only when there's a block time given, railways are not supposed to run. It was given every 2 days, midnight, 12 midnight to 2 a.m. after every 2 days. Within that, you had to perform, end date was fixed. So it was quite a challenging project to construct. To my feeling, that is the fastest structure construction, because in those constraints the structure has been constructed. It's remarkable. Of course, we are the designers, no doubt. Another interesting one that's in Bangalore, precast segmental overhead launching, epoxy jointed, internally pre-stressed, post-tension, blah, blah, blah. But the good thing in the structure here is you don't get the tuck, tuck, tuck traffic noise every 20-30 meters. The expansion joints are spaced about 262 meters away. And it's a 10-kilometer long expressway. You get tuck, tuck only after 1/4 kilometer. So these are all the operations. Structural construction had to be fast because this is a BOT project. So they had to start operating the traffic and collecting tolls very fast. And as a result, the superstructure construction took something like 3.5 days per span. Using a system of launching entry, etc., that you saw just now, and their wireless remote control launching entry. So all its operations that we see of the segments going up and down, transverse alignment, longitudinal alignment, movement of the launching girder, everything is controlled by this little remote. All right, so we come to Bangalore metro structures all over the country. China, I believe, already has 1.6 kilometers of metro. Russia, more than half a kilometer. France, about half a kilometer. Germany, India is also now at about 420. But looking at the size of the country and looking at the population we have and looking at the traffic that we have, we need perhaps 4 or 5 kilometers by now, perhaps 10 times of it by now. So we are far behind, I must say. But as of date, some 20 to 22 cities are constructing metros, or they have been permitted to construct the metros. Our very first experience was in Malaysia, Kuala Lumpur Metro, 26 kilometers. Planned timing for this was 2 years, sorry. Precast segmental, dry matched, externally pre-stressed. That's a thing here. I'm hearing some message. Okay, all right. So this is a technology that is an underslung launching girder. It has a portal. Over the previously constructed structure, a trailer comes, brings a segment picked up by the portal and puts it here. Now let me tell you, in both these structures, one is the Bangalore elevated expressway I talked about. Although construction of the superstructure took something like 3.5 days per span, but despite of that, due to several foundation related problems in the rock and other things there, structure took finally several years. It was not like 2 years or 3 years, it was much more. So let us be honest about it. Very similar to that in Malaysia, this metro project, that was our first metro project, and I think anybody in country was the first project of metro. Again, the period given was 2 years, but due to certain financial constraints and maybe something else, it took several years to complete. So this is the external pre-stressing, where the pre-stressing cables are not into the concrete, they're outside the concrete in the hollow space of the box. That has been the concept. After, in fact, all this, when I gained the experience, I prepared a code IRC SP65 in India to be followed for all the segmental constructions. In fact, all this segmental construction, precast or in situ, both, including splice girders. Now, when we go for a speedy construction, this picture I've taken from a metro from Noida to Greater Noida in outskirts of Delhi, which we designed. They constructed 30 kilometers in 24 months, perhaps a world record. India can also make a world record of speed. The reinforcement was cut and bent and supplied to the casting yard through this PNC and CNC controlled machines, hydraulics and everything is a part of it. Everything goes very, very fast for the 30 kilometers because everything has to then be matched. And we have to match the design speed as well. All right, so come to sustainability I was talking about as the main aspect. The world produces 3.6 billion tons of cement. India alone produces about 1/10 or 1/12 of this 3.6 billion tons of cement. And every ton of cement would produce 950 kg, almost a ton of carbon dioxide, giving you greenhouse effects, undesirable aspect. So if we can reduce the quantum of concrete, we have done some of our job. So we should use materials that are more friendly to the environment. And new IS 383 permits use of recycled aggregates. That's another thing, because then we reduce on the, or you conserve the natural resources you have. SP70 encourages use of mineral admixtures like fly ash and ground granulated blast furnace slag. You know very well that we live in the world of finite resources. We should not think that lime will keep coming. You keep using it, it will keep coming. There is certain limit, certain cap on it. There are various codes that give you how to make the structures durable. When you make the structures durable, you don't have to demolish and you don't have to sort of rebuild, and therefore you conserve your natural resources. Okay, how to reduce carbon footprint is by simply reducing the volume of concrete utilized or volume of construction material utilized, you reduce carbon footprint. This is a 25-story building we designed for a hotel in Bangkok, where all the floors here that you see are cast in situ, but pre-stressed. As a result, 4 meters long cantilever has a depth of only 40 centimeters of the beam. 8.2 meter span in the longitudinal direction, has a slab which is also only 200 millimeters. The beams are pre-stressed, the slabs are pre-stressed, post-tension of course. So when you put pre-stressing in the slab, you have this kind of flat pre-tensioning or post-tensioning, sorry, arrangement with the flat cables, flat duct, flat everything, and flat anchorage cone, and therefore jack as well. We talk of precast pre-tension and precast post-tensioned. Both are pre-stressed. When we make it post-tensioned, which is a common thing we do in most cases, the thickness of the section is more, and therefore the concrete that you consume or the cement that you consume is more. But when it is pre-tensioned, there are no ducts inside, there is no grout inside. Pre-tensioning strands, it's only strands, not cable. They work just like a reinforcement, but active reinforcement with a pre-stress. The thickness reduces. So in this project of Delhi Gurgaon Expressway, 1800, the largest number of pre-tension girders were used, largest in the country on any project, and each girder was much lighter than its equivalent post-tension in terms of material, weight, everything. And after this, I have prepared a code, IRCSP 71, for design of precast pre-tensioned girders. Look at this famous project. I think all of us know Bahai Temple in Delhi. In this project, they have used all white cement. And when it's a white cement, the problem becomes how to make it last about 200 years, 300 years and all that. Slowly, the air, the carbon dioxide gets inside. The concrete breathes and the reinforcement corrodes. Once the reinforcement corrodes, it swells. Once it swells, it cracks up the concrete. Once it cracks the concrete, it further breathes and further you have a corrosion more and more. So apart from all other aspects and many aspects, including shading the aggregates, using ice cold water and so on and so forth, in this case, they've used galvanized steel, galvanized reinforcement to enhance the life, because galvanizing can then take another few years for it to move away. You can also have stainless steel, which is of course more expensive. Look at this. Oh, I have 5 minutes, I think. Look at this, another interesting project on outskirts of Delhi while you go from Delhi to Chandigarh side, GT Karnal Road. A typical outer ring road, typical 4-leaf flyover to make left and right everything signal free. You notice also there is something called a drain, a big city drain with a width of 50-60 meters. But there are a few other complications I will show you. Here we said, fine, let us make it change. Let's go for steel structure. Reduce burden on the concrete. So here what you see is hollow box, steel of course, box means hollow box, made in the shape of a box with inclined webs, with a concrete deck of course for movement, and whole thing is steel and steel except for piers. So superstructure, at least you have discounted the concrete more or less. The rounds that you saw, I mean the curves, all the clover leaves, they are made into curved and curved structures like this, which are cast in situ, voided slabs, and RCC in this case integral. Okay, let's not take too much time. Apart from other complications, the major complication we found was that there was a landfill in one of the quarters of the on one of these sides, this side, there was a major landfill, height of about 18-19 meters. If we move all this material to somewhere, first of all, we have to find a location where to move. Secondly, moving time itself was given as 6 months and the cost. So we did something that we said, okay, let's have a married life, happy married life. You live, I live. So what we did was something like this. All this is there. And it was so funny that if you go there, you have to close your nose. You can't smell, it's so smelly. And you put your foot, the foot depresses into it. It was so bad. But despite of that, we made a structure for those ramps, the clover leaves, something like this. First, we hardened the ground locally for the inner pathway. On that hardened ground, a piling rig could go, and piling was done like this, as you see. And over the piles, we have placed a slab, which is supported on the piles, but the landfill is not moved. It is there. Over on top of the landfill, we have done all this. Now what happens is, after doing this, we have put these landscape. See, all that ugly landfill is inside. Over the is here also. Over the landfill, we have placed these gunny bags, soil-filled bags with seedlings, and those seedlings have started growing. So the people who would feel the smell are not feeling the smell, rather they're enjoying watching this beauty. So that's how we kind of created a marriage between us and the landfill. This is of course a picture from Extra Dose Bridge, Barapula, that's under design and construction, designed by us, construction by L&T. Some pictures. Extra dose means short pylon, and pre-stressing is sort of outside, you can say. Now for economics, there are two things done nowadays. One is you make a spine wing segment, wherein you have a spine and you have these wings. I mean, it's not this case, but wings, which you construct separately. So transversely also you have 3-piece assembly, and longitudinally anyway many pieces. Other is you do like this, which we've done for Barapura, this phase 3 project, the extra dose project, wherein the segments have these struts inside, so that even the wide segments, which are 70 meters, 20 meters and all that, do not require a third web. Instead, the job of supporting the slab and reducing the slab thickness is done by these struts, and everything else is outside. Oh, engineers, they have reasons to pride and pat on their shoulders. A world record bridge. They started the construction in Japan, in Kobe state of Japan. In Kobe, Akashi state, sorry, name of the state is Akashi, in Kobe, with a span of almost 2 kilometers unsupported. There's a deep gorge in the sea, and they had to construct this bridge necessarily there. They started a construction in 1989, finished in 1999. That was the official completion period. The realistic estimation of the construction period is also extremely important. Keep in mind. So the interesting thing here is that the suspension bridge, these pylons, of course, are steel pylons. They are almost 300 meters tall. There are cluster of well foundations, not one, multiple wells at each location. And the deck, which is 35 meters wide in steel, is supported by two main cables. Each one has a diameter of 1.122 meter. Each one has a weight which is almost 10 tons per meter. The total weight of this 4-kilometer long cable is 40,000 tons. How do you carry this 40,000 tons across a seabed from one end to the other? So they used a combined power of high capacity barges and high capacity helicopters to carry each cable across a seabed. That is how they could carry it. Anyway, so there was a stage in 1995 when well foundations were done, pylons were erected, both these pylons, suspension cables were just erected, not the verticals, but at least a suspension. Deck was not done, and God was merciless. In 95, there was a famous Kobe earthquake. This Kobe earthquake shook these foundations because there was a shaking in the seabed, and this foundation shook in such a way that this went outside. It went outward by 80 centimeters. And not only went outward, it also tilted. Because when a rock moves or bed moves, it also tilts at the same time. As a result, the pylon tilted this way, inward. Rock moved outward, tilted anti-clockwise to this paper, and pylon moved inward towards the middle span, and this cable sagged 1.3 meters. Now everybody lost everybody lost his cool. What to do? The whole ambitious project, 6 years into it, 89 to 95, and now we are back to the square one. So with the given conditions, it was given to the engineers as a problem to solve. And they found, fortunately, that the same design as it is with these things, with all this catastrophic stuff, was still safe. And they went ahead with the construction, finished the structure in 1999 as they were planned to. Then it became more difficult for you and me to break this record by 1 meter. 1990 had become 1995. 0.8 precisely. So basically what we are saying is that engineers can do wonders. We have a great role to play to the society, and India's growth, looking at whatever structures I have discussed, many of them in India or most of them in India, we are poised to touch sky. Professional institutions, the knowledge partners, the institutions like KLU and many others, they play a very vitally important role in the success of this world. So thank you so much. And I hope we have a grand success of the event and we have a lot of good memories out of the event that we have. Thank you so much.
Thank you.
Wow.
Thank you very much.
Thank you so much, Vinay sir. Thanks a lot. I mean, in fact, it's been a world tour of durable, sustainable, and aesthetic construction technologies, and it's so lovely to hear it from you, and especially about the 2 hours gap you said about the Nizamuddin railway line between Delhi and Mumbai. That was amazing to know. You have in
It was a
fact given
nightmare,
sort of
nightmare
enlightening.
at the night.
Yes, sir. It was something interesting to know. In fact, it was amazing. Thank you so much, sir. Thank you for giving us time. And
My pleasure.
And we have upon one of our conference chairs, but right now we have him with we have him with us. It is always a great honor for me to introduce and welcome the conference chair, Dr. G. Venkatappa Rao Garu, former professor and head of the department, Civil Engineering, IIT Delhi, visiting professor, IIT Gandhinagar, and chairman, GTAS chairman, and Geosynthetics Division, LRL. He merely requires any introduction, in fact. He is well known for his work in the field of civil engineering in the current era. He is one of the masterpieces that not only has critical acclaim, but also have international recognition. Moreover, he is profoundly loved and respected by his colleagues on whom he has got great influence in creating their path. With that being said, let us call upon Dr. G. Venkatappa Rao sir, Professor, Department of Civil Engineering, who is a visiting professor in IIT Gandhinagar. I request him to take over and speak a few words about this conference. Sir, you may.
Hello. Am I
Sir,
audible?
you are audible? Yes, sir, you are. You are.
Dear colleagues from KLU, respected Mr. Vinay Gupta, Chief Guest of our function, and all other experts who joined for this annual function. At the outset, I beg my apologies for having joined late, but I enjoyed at least more than half of Mr. Vinay Gupta's presentation. It was wonderful. It was an eye opener for all of us that such great things are being done not only in the world but also in India. And he has given very brief, of course, overview of many things now, of which I think the conference definitely feels is an addition to the knowledge bank which they are creating for this purpose. I think advanced engineering is something which we need to keep updating ourselves now. And as you rightly mentioned, today we have a lot of issues. I mean, but not only the shortage of, let's say, cement as usual, and even steel and bitumen and whatnot. Being a dual engineer, we find that even aggregates are small. I mean, not available really freely because of restrictions posed by the government due to reasons, valid reasons. Even sand is not available. And for all we know, even soil is not available actually. So under these conditions now, to be able to build infrastructure, as I said, which can last, say, 100 years or more, is really a challenge. And that this is being taken up by our colleagues in the civil engineering industry, as well as colleagues in the construction industry, and of course, commissions, is something which we cherish. But then we only wish that, as an academician, that all these things become part and parcel of our teaching also. That's why I'm happy that many students have joined for this also. And the advances are, of course, in one way, given overview only. And we, of course, have many more occasions to really participate and learn more about what is really happening. That means the conceptual design of most of the structures which Mr. Gupta has mentioned, because he, of course, covered everything very briefly, but each of the aspects he covered requires much more in-depth study of not only conceptually, but also design, construction. In fact, it is a construction scheduling which is becoming more relevant now, because every one of us, including the government of India and other state governments, would like that the moment we have conceived, they would like the structure to be ready, let's say, very shortly, and definitely well before the elections. So that being the state of affairs in the country now, it's a great knowledge bank which Mr. Professor Hanumantrao and his colleagues have created at KLU, and joined by many experts throughout the world. I'm very happy to be part of it now, and I wish this event with such a great beginning, a great success in these 2 days now. Thank you very much, and wishing all the best. Thank you.
Thank you so much, sir. Thank you. Thanks a lot. We are really honored to have you with us. Thanks a lot, sir. Now here comes the time to release the conference souvenir. So I would like to request both the chairmen, Dr. G. Venkataparov Garu and Dr. G. Aparov sir, and also our chief guests and guest of honor, Vice President sir, Suresh sir, and Vinay Gupta sir, who is the president. So it is like, basically one of our conveners is going to display it. So you are going to just say it is open, or is released. So that's it. That's how it is going to be. So you may just display it, sir, Harsha sir, the conference souvenir. So it is a collection of all the abstracts that we have received, all the 240 abstracts for the conference.
Yeah.
So here you go.
Ask the chief guest. Ask the chief guest to that one.
Yes, very pleasant moment for me that we have a fantastic souvenir. I've gone through most of it. The good thing is that we received a fantastic response, something like 240 or 245 abstracts, which are there in the souvenir. And I believe there are 175 full-length papers as well out of 245. And out of them, the numbers that are being presented in this conference are also more or less the same. 167 numbers are being presented. That's another good number, which includes about 36 keynote addresses. So my great congratulations to the entire team who has put together so much of it into one volume. And people can, of course, good thing they have done is also that you people have put these contact details, email IDs and all that. So if somebody wants to know about somebody, talk to somebody, or rather at least communicate with the author, you have the way how to reach the author. That's very good. Thank you so much, and good luck to you all. And one more thing, I heard that several papers will be published in the indexed journals. That's another good value that will add to the event. Thank you.
Thank you, sir.
Thank you.
Yeah.
Thank you, sir. Thank you so much. Thank you so much, Venkataparov sir, Aparov sir. Thank you so much, Vinay sir, and thank you so much, Suresh sir. Thanks a lot. So now, at last, I would like to welcome our one co-convener, Dr. P. Polraju sir, to give the vote of thanks for this inaugural address. Sir, you may please go ahead.
Yeah, thank you, Dr. Hamim. Yeah, first of all, good morning to one and all. I welcome you all for this 2 days international conference on advances in civil engineering on 25th and 26th. Yeah, it's an honor to have been asked to offer a vote of thanks on the occasion of the 2-day international conference on advances in civil engineering during 25th and 26th June 2021 in Civil Engineering Department. On behalf of Civil Engineering Department and the entire management group here, I am very hearty gratitude to all the keynote speakers for sharing their graceful words in the international conference. The Honorable and respected Chief Guest, Engineer Vinay Gupta Garu, President, Indian Concrete Institute, and Guest of Honor, Engineer S. Suresh, Vice President, South, Indian Concrete Institute. We have been fortunate to have of the renowned identity from academic and industry area. I am very thankful to conference chairs, Professor G. Venkataparov Garu and Dr. G. Aparov Garu for their valuable inputs to the international conference. I am very thankful to all session chairs and co-chairs for their support in chairing the sessions in the international conference. I am very thankful to advisory board of this international conference. I am very thankful to technical committee of this international conference. I am very thankful to Dr. N. Venkatram Garu, Pro Vice Chancellor, and Dr. K. Subbarao Garu, Principal, College of Engineering, for addressing to the conference inauguration. I am very thankful to Dr. C.H. Hanumantarao Garu, HODCE, convener of the conference, for his great support to conduct this conference. I am very thankful to all authors and participants for their active participation in this international conference. I am very thankful to organizing secretaries of the conference. I take this occurrence to thank the entire organizing committee of the department. I also thank IOP Conference Series, Material Science and Engineering Conference Proceedings, for publishing our selected papers. I am very thankful to KLU Management, Honorable President, Engineer Koner Satyanarayan Garu, Vice President, Engineer Koner Avish Garu, Vice President, Engineer Koner Rajaharin Garu, for their support to organize this international conference. Once again, at last, I thank to all. I thank everyone. Thanks for giving this a great opportunity.
Thank you. Thank you. Thank you. Thank you.
Thank you. Thank you so much, all the dignitaries who have joined us. So now I request the track coordinators to kindly start your tracks so that the session coordinators will be joining, and all the chairs and the keynotes, whoever are responsible for your sessions would be joining. And in the same track, basically in the same link, the structural engineering track will be going on. So all the structural engineering participants would be asked to stay back in this link, and rest of the participants would be joining in your respective track links. Like, for the track 2, we have construction materials technology and management. Track 3, geotechnical engineering and transportation. Track 4, we have environment, water, and GIS track. So you would be asked to join there in the respective links, which will be shared in the WhatsApp groups, so you can join over there. So thank you all. Thank you once again for joining in this inaugural session. Thanks a lot.
Thank you, Dr. Hamim and Sri Harsha, for organizing this inaugural session wonderfully. And I thank all the chief guests, guest of honor, conference chairs, and convener Dr. Paul Raj Garu, organizing secretaries, organizing committee, all the keynote speakers, chairs, session chairs, co-chairs, and participants. Please join in your respective sessions. The sessions are going to start sharply by 10:50 in 5 minutes. Thank you all. Harsha, please keep the session here.
Yes, sir. I'm going to start
Thanks.
section 1, sir.
Yeah. Keep the keynote speakers. Professor Appara sir is there, so.
Yeah, I'm here. You just allow me to present, right? You give me.
Yes. 1 minute, so just we will keep the slide regarding your profile, and then you will do this.
Okay, sir.
Before that, you introduce the chairs and co-chairs to the session.
Yes, sir. Sir, waiting for chair to
Java Srinivasa sir joined, sir. Good morning, sir.
Sir,
Good morning, sir.
Sir, 1 second, sir. I am giving post, sir. Yes, sir. Good morning, sir. You can speak, sir.
Congratulations, sir. Hanumantrao and Paul Raj garu.
Thank you, sir.
Asha, you can keep the SARS slide. Chair slide. Make it bigger.
Sir, Appararu, namaste, sir.
నమస్కారం నమస్కారం బాగున్నారా?
బాగున్నాను సార్.
Nice to see you in this pandemic situation.
Yes, sir. రావట్లేదా సార్ ఇటు విజయవాడ?
Yeah, no, Chennai only. No Vijayawada. There are no. Okay.
Make it.
I think, sir, Venkatraman garu is there, sir.
Yes, sir.
Sir, good morning. Namaste, sir.
Good morning, sir. Good morning, sir.
Namaste, sir. Srinivas sir, namaste. Apparao sir, namaste, sir.
To see you.
And I'm just switching on the video, sir.
Yeah, video.
Good morning, one and all. Good morning, one and all. I welcome you all once again to the structural engineering session.
1 minute. Asha, stop your YouTube live streaming.
Okay, sir.
Yeah.
Yeah, now you can start.
Sir, can we go ahead with the introduction of Apparago?
Yes, sir. Good morning, sir. I would like to cover conference chair, Dr. Chava Srinivas, Professor and Head of the Department. I welcome you, sir, once again for our international conference on advanced in civil engineering on 25th and 26th July. Welcome, sir.
Okay, I welcome you all, especially Dr. G. Apparao garu, who is an eminent professor at IIT Chennai and our well-wisher. And I request you to present the keynote lecture, sir. Before that, a brief profile of Apparao, sir. Dr. G. Apparao garu has obtained his PhD from IISc Bangalore and completed PDF at University of Stuttgart, Germany. During the 30 years of his service, he was a scientist at SASC and he worked on structural materials, RC structures, and earthquake-resistant design, bridge structures, fracture mechanics, fastening techniques. During his career, he has received many outstanding awards like Alexander Van Humboldt Fellow, Dr. G. Apparao garu awarded with the DIE SRC Outstanding Investigator Award, DST Young Scientist Awardee in 2002, EDF Stipend of Excellence Awardee in International Association of Fracture Mechanics for Concrete and Concrete Structures, and DST DFG Collaboration Fellow for a while. He published about 240 research papers in various international journals and conferences and received several Best Paper and Best Thesis awards. I call upon Dr. Apparao garu to present his keynote address. Sir, please, sir.
Something. Yeah, now it's connected. Yeah.
Good morning, sir. I have given presenter rights to you, sir.
Okay.
Yes, sir. We can see our slide, sir.
Yes. Okay. So very good morning to you all, and welcome again for this technical session. So I would like to deal with my technical talk on fatigue related things, because engineers or researchers from institutes where they don't have the facility, but they cannot venture into the fatigue or cyclic testing. And very few laboratories we have this facility, but very often we come across what actually fatigue and cyclic, but a kind of description of this fatigue, a little bit of fracture related flavor. And IIT Madras, actually, we have been working with industry and to solve many problems like characterizing the structural systems, because it may be IIT Madras or it may be any other institute, or the venues like right now we are sitting, okay, we are sharing on a common platform. So it is something enriching the knowledge, okay, or disseminating the information to the people. Okay, so actually when we deal with like academicians, so and we have some standards to describe various processes involved. So engineers, okay, straight they deal with okay design codes and go ahead with the whatever mentioned in the designs and drawings. But actually, we, the academicians and researchers, we have to have authority to come out with standard documents and testing procedures. In the way, like we are meeting now. So these disseminations, okay, discussions, finally, when we compile and submit to the appropriate organizations, they will amend in their standards. That's how they think, right? So it's a big process, starting from the like laboratory studies, then analysis, then coming out with some kind of authentic conclusions, then submitting to the technical committee and approval from them, and again core committees. So in this process, so we have to understand what actually the fit is, because so very often most of the structural elements will undergo like a fatigue loading or cyclic loading, maybe different sources of forces. But in general, the fatigue, okay, is described as it's related to material. It's a behavior of materials, particularly important. No, repeated cycles of stress or strain, whether it's a load control system or strain control, okay, or displacement control, but whatever may be the way you transfer the loads to the system, material undergoes deterioration with time, with a lot of more number of loading unloading cycles, but eventually it leads to progressive failure. It is like a time taking process. It's very, very slow, but it's a hidden and nothing is visible, and we cannot immediately predict how they are going to fail. But wherever we have fatigue loading or a repetition of similar stresses or strains, material undergoes some kind of internal deterioration. It will take some time. The claim here is all structural related products should be designed for such loads. So the important claim you have to understand is the design for fatigue. Okay, when a material is subjected to any kind of time dependent or say maybe a kind of different forms, whatever may be the case, but so you cannot neglect. You cannot neglect. Okay. So now actually when you understand when the structural system is subject to loading, you talk about the internal things. So you have damage mechanics, fracture mechanics, they deal with the internal defects. Whenever we have the internal defects, there will be localized, high raising stress levels. So stress concentrations. But you don't understand that, but they are so dangerous, you know. So they will lead to like a localized plastification, like micro crack formations, then whatever may be the form, even in concrete. So all like, you know, manufacturing defects, okay, during production, lot of other things, the water filled gaps left out after expulsion of water. So they're all like a kind of defects. But you know, again, the fatigue, it is hidden actually, and it's not sudden. It won't happen immediately. It will take little time. Now, for example, I'll demonstrate, say, it is a steel member or a concrete member, structural member, a defect, okay, it is unseen, okay, we cannot see outside, but you know, it is existing. But with the number of loading, unloading cycles of stress or strain, whatever, so this one, it's like, you know, pulsating type, like, you know, loading, unloading. So it's a repetition. For example, a typical example is a bridge. Okay, you take like offshore structures. Okay, maybe members subjected to like, you know, wind, alternating winds, okay, morning, evening, or wave effects, whatever may be the case. Or say you take any kind of fluid, okay, storage tank. So then you fill it, then empty, filling and emptying. It is like a process of loading, unloading. But somewhere, due to some reasons, a defect exists. The defect, so due to loading, unloading, it grows continuously. So finally, it will lead to complete destruction of the system because the whole cross section, okay, gets deteriorated. Due to that, actually, it's a very dangerous process leading to strength loss. Then, of course, when you have repetition of loading, for example, take a rebar, bend, rebend, what happens? You know, its characteristics will change, and the ductile material will become brittle. When that is the case, so uncertainty, it's highly unreliable to predict the strength and life because we expect 50 years, but subsequently we come across a precast system 100 years. But you know, when you have these repeated loading and unloading, and the prediction is highly unreliable. So then actually the causes of this one is important thing in the materials, imperfections, any form. Imperfections in any form. So therefore, when the mechanical engineers or aerospace engineers or civil engineers, when you deal with the metal structures or say, or quasi-brittle materials or any, cementitious materials, so we need to understand the factors influencing. So it is something, any form of defect, notch, or something discontinuity, or maybe change in the cross section, instead of suddenly, maybe gradually, and uneven surface roughness. Naked eye we can see maybe it looks horizontal, but when we see the microscope, there will be undulations. And any feature that is leading to stress concentration. That means the concentration is, so actually you take rebar for advantages, reasons. So we change the surface characteristics by providing a kind of deformations or protrusions. But these protrusions will develop a kind of changes in the stress level. So there sudden changes in the stress. So this will be like a discontinuity. The flow of force will be discontinued due to sudden increase or sudden addition of some deformation, protrusion. They're actually localized stresses, concentration. Then during fabrication, of course, you will have, so alloys will be burned, and then you join the steel member, and then the temperature effects. Now in India it's fine, but other countries, the nighttime temperatures will be like -20 somewhere, sometimes. So -20 and the daytime say +20. So maybe 40. This is good enough for any defect existing in a structure, leading to failure. Not suddenly, but it will take some time. Then again, another thing is the rate of load. For example, take vehicles. So when a vehicle, like running at a speed, say the bridge is designed for say 60 kilometers per hour. Say when you run at say 120 kilometers per hour, then the forces exerted by this effect, it has some consequence on the structural members. But then actually it is designed for say 50 years and with a minimum load and a maximum load. But when in between, when the loads are exceeding, like a kind of accidental loads, so then the whole function of the system will be disturbed. Then important thing, we come across concrete structures, so corrosion related thing. Corrosion related things also it will come under fatigue cycling. So these are all the things, they look very simple, but the strength, then the remaining life of the structures are hampered by all these factors. Now, actually, when you understand what is fatigue like, it is this is like a number of loading, unloading. See, bridge system is designed for a given traffic loading. When you say class A bridge, so its ultimate load is maximum load is defined, minimum load is defined. Class B bridge, so the limits are different, and class C bridge. So you cannot allow the vehicles to pass through class C bridge like in a class A or class 70 or say category. So there actually they cause very high stress levels and the life will come down. So for example, the number of cycles causing fracture, so the design stress minimum and maximum stresses will be limited. When you limit that one, then you calculate how many vehicles are crossing through the bridge and how many years it requires. So that is number of vehicles passing through in 50 years. That's the life. For 50 years, how many cycles, how many vehicles will pass. And the fatigue strength, it is the strength of the particular system, the highest stress at which material can survive. So when I say n number of years, in n number of years, how many vehicles can pass through when I maintain this much maximum stress. So maximum stress is limited. For example, in steel, let us take 165 newtons per mm square is the stress limited. But actual ultimate strength may be 600 now, the existing steel. So then there is a factor. But sometimes when the accidental loads are acting on a system, and what happens, the stress level in steel will exceed its limit. When you exceed the limit, what happens? There is some kind of permanent set. That is one reason when the overloads are acting on a system, so it can cause even immediate collapse when the stress is exceeding, or otherwise the life will come down. So therefore, that's what when you design, the limits are clearly defined for the design values. And the limit, this is, you want to design structural engineers, we have to ensure the safety of the building for the life, how you design. So let us take precast elements 100 years. When you say 100 years is a lifespan, in 100 years, so you need to fix the stress level so that it should never fail. Any number of cycles, so like any number of years, it should not fail. That's how the structural systems existing today intact, they were designed so that the stress levels are so low. Even under say 100, 200, even many 100 years of, they existed, they survival. So they are still functioning well, they are intact. But then now anyway, changing things, we think something for other functional requirement. And clearly the fatigue can be described through the stress, maximum stress, and the number of cycles. It's very, very clear. The structure designed for 100 years, then we can have the maximum stress. Maximum stress is limited. Suppose if the maximum stress limit exceeds, then what happens? The life will come down. Life means the number of cycles. Number of cycles per day, how much? Per month, per year, and for the life of the structure. So you need to calculate, it may be 2 million or 3 million or more than that. But then actually more practical structures constructed in the many countries, firstly, industrial revolution. There are, of course, many European countries. The country they started with steel construction, then they exhibited a kind of failures, due to unknown reasons. But of course, all weather-related things or load-related things, changes in the loading pattern, stresses develop. They were not, aware. And of course, in the beginning, when the structural system was supposed to be designed by an engineer, the engineer has to be an expert in that field. when the structure is designed, say bridge, then the engineer who designed should be standing under the bridge when it is loaded for its design load. Suppose it fails, then that is a punishment to him. Otherwise, anyway, this is some kind of like, it's a error, trial and error procedure kind of thing. But now over the years, we got a lot of information. We come out with the standards to design. But now the variations are reduced. Now reliability is improved. So during World War II, many steel or say iron bridges constructed in European countries. So suddenly they failed, but those reasons were not very clear. Like that, many civil engineering structures, like now bridges, steel bridges or say concrete bridges, or any other a system which undergoes some kind of loading unloading. You take your vehicle. So when you give say servicing today, then it may work well up to say few months. But afterward, then you find some different. That is due to fatigue. When you are taking, then a lot of loading, unloading things will be there. Then all the parts of vehicle will be some kind of servicing is required. Like this, any structural system subjected to loading. Now, actually, it's very, very important for us to understand what are the loads actually to be applied. What do you mean by cyclic loading? Actually, when you want to test heterogeneous materials like concrete or ceramic materials, so then the stress levels cannot be in tension. The stress levels always be in compression. They will be subjected to minimum compressive stress and maximum compressive stress. Of course, the ultimate strength will be known. So then actually the stress levels are always in compression. This is something like pulsating time. Mostly this process will be applied to ceramic materials and concrete. And the reversal, partly reversal, maybe in pre-stressed concrete structures when you induce initial compression. Now, actually, the complete reversal, maybe steel is strong in both compression and steel. So it's like a sinusoidal loading can be applied, in steel, like positive and negative stresses. So there actually the engineer has to understand what exactly the characteristics required for you to define a cyclic or fatigue loading. Very, very important. Blindly, you cannot do that. The frequency is very, very important for a given frequency, for the given design condition. So you need to know what is the minimum stress and maximum and the mean value and amplitude, the difference of the maximum stress and minimum stress, and of course these values. So from that, the cyclic loading defines a stress ratio called what is the minimum stress applied and maximum stress applied, that ratio. Depending upon that, the performance of the structural system varies. So here we define the ratio. Then this is related with the maximum stresses and the difference in the stresses, and even deviation in the stresses can be obtained. These are all interrelated. Anyway, the civil engineers, when something is given, structural engineers, something is given, some other parameters can be prescribed. As per your design, I fix my requirements. My life is say 100 years. When this is that N is say clear. When N is clear, then actually this one is what is the dead load. So that is what is the span. What are the materials to be acting? Then subsequently, what will be the vehicular traffic? I can fix the maximum. So for these conditions, I will get. Now actually just preliminary understanding. Now actually, if a material is subjected to repetition of loading or say strains, whatever, then actually you understand simple wave fracture related thing. Whenever there is a material level, internally, and a defect is existing, a flat crack-like structure, then actually the stress levels are so high that there actually the state of stress is described by the term called stress intensity. Anyway, so maybe a little bit fracture mechanics you can understand, but it's only for understanding, but how the process is going to be applied here for designing the bridges. So now actually we will be very much interested in dealing with how the cracks, because so normally the structures will be designed depending upon partially pre-stressed or fully pre-stressed normally or say class 1, class 2, class 2 type, class 3 type. But whatever may be the case, when you are related with the crack propagation with a number of loading unloading cycles, it related to the crack size inside and the stress, state of stress in front of the crack tip. But whatever may be the case, all railway bridges the railway codes prescribe design of elements for cyclic loading. They mention what is sigma B naught, that is the stress in steel. Okay, and also they use the relationship between the crack length, crack growth versus the number of cycles. This is called Paris law. When the Paris law conveniently converted for design of a reinforced concrete bridge element, this comes from this. The Paris law gives you relationship between the damage related things per number of cycles. Okay, and that is related to all structural parameters. Conveniently, you can convert all of them in terms of stress. What is the maximum stress you apply and minimum stress apply? Just it's only understanding. That means there is a clear understanding required, or the relationship between the material parameters to be connected. You have to understand that the damage in the structural system, it's related to the number of cycles applied in other way. So of course in fracture mechanics term we can, but in strength of materials terms, okay, our structural design, we have maximum stresses and minimum stresses. Damage or life is directly related to the stress range, minimum stress and maximum stresses. That is something, okay, important to understand. And important thing is most of the structural system like concrete, so it will have some kind of variation of strength with, okay, size. So you are aware of the testing of cubes in the laboratory, you will find it, but that we assume as the structural strength. But in reality, that is not the one. But in reality, practically, the strength achievable in the structural system, it is something slightly lesser than the laboratory strength. And when you take very huge, like a dam-like structure, huge concrete will be used. It is like infinite body. And you take a cube tested in the laboratory, it's a small, and based on that small body, you take the results and apply to the real structure. But in real structures, the strength varies with size. Strength decreases with size. That is clearly understandable when you understand the size related things. SI code has given this description, and it was like a comment form, but now in the design form. So for all design purposes, the structural design for shear will be done incorporating the size of the member. Now, actually, again, when you're talking about fatigue, fatigue also related to the size. So crack growth mechanism is required, then permanent degradation is happening in concrete, then cycles are required to fail the material. So these things are described in ACA 215 and even IRC. Okay, that is how the cyclic loading should be considered in the design. Now, actually coming to this one, people are talking about precast system or prefabricated system. It is important thing, I'll emphasize the influence of long-term characteristics of material. So creep and shrinkage, when you have the pre-stressing force. Creep and shrinkage when you have in precast system. It is complex, very, very complex. Creep shrinkage is not very clear, but when you have this segmental construction, a lot of pre-stressing is being used in the transverse and longitudinal direction. And when you are combining, joining different components to have system. But anyway, when you're talking about precast system, these are all the important factors to be considered. So we have to look into the life, we have to look into the cost involved, and the energy consumption, particularly whether is there any cast in situ kind of thing, energy consumption like in the form of cement, carbon dioxide produced, and performance in the long run or short run, and maintenance requirement, then reuse and recycling. That means these are all the things to be considered, but the standards are very clearly long back have come out with standard like say ACI, PCI, and FIP. These are all the two standards in the world, in the European region and American system. So they also clearly, granted that the engineers can use precast system and pre-stressing system wherever you will find the conventional concreting. So in buildings, parking structures, construction of stadium and railway sleeper, transmission, and many more. See, I cannot list now, but wherever you'll find, we have the long road system, we have many canal systems, we have many infrastructure projects are coming up. Wherever you are thinking about construction, mostly 90% of the cases concrete, you think about precast system. When you think about precast system, all these characteristics described will play significant role. is a typical construction involving elements gathered from different factories, okay, position supported. These are all the things like a few days back, okay. So what is the 10-story building? How many hours? 28 hours. Yes, that is this one. It is, I mean, it's ready made. It's already, everything is ready. It's not really in actually 28 hours, but foundation was constructed long back. Then all the elements were prefabricated. All provisions were made. Then actually it was like a long process, but joining them, it took maybe 28 hours. Okay. I mean, it's a number you can put because the slab system, beam system, everything together is a combined with the precast system can be done. Right. Then this is something, okay. So because IIT Madras, we also worked on many projects related to characterization of prototype walls, which are directly usable in practice. So this is like, so we have sandwich precast system. So anyway, the long-term and short-term performance characteristics are required. This is the typical, okay, conference hall is a big one. All the walls are from, okay, ready-made walls, okay, like the shape as you require. Then they can be positioned, and maybe for ventilation purpose, glass panels can be. This is another storage tank, okay, some other system. Okay, all the wall panels are precast elements. So you can bring them. These things are readily available, are prefabricated, and you can transport to the site and join them. This is something important. This involves characterization of the precast elements, characterization of the joining medium, that is a glue or cement paste. And when you do circular pre-stressing or transverse pre-stressing, that is also important. When you do pre-stressing, the characteristics are important, behavior is important. Actually, this is something, a mega project we have done. So then different walls have been proposed, designed with different parameters involved. Then we tested short walls and long walls, and we understood how the behavior. Then we proposed to go for like ground +1, +2, +3, and up to 5. And even actually we should understand how their behavior under the cyclic loading. So these large size walls, okay, almost like 5 meters, 6 meters tested at IIT Madras. Then actually before that, even precast system or any structural system, when you're talking about cyclic loading or say, okay, fatigue loading. So basically this is okay, earthquake loading. That is also comes under that category. When you have this thing, when you take the system, like a building system, when the building subjected to like this ground motions or blast effect, okay, or say a windstorm, then definitely it is going to be vibrating. It's going to be changing its stresses, okay, very frequently. The frequency matters. Then the stiffness of the joining members matter. Then the failures will be somewhere which we don't want to happen. But to protect such buildings, we need to go for retrofitting. So locally, you need to strengthen the system there, the cyclic behavior of the existing system and the cyclic behavior of the retrofitting system is required. And there actually a lot of research can be concentrated. Now, actually, when you're talking about joining of bridge element, like a segmental construction, wings and the main beams will be connected through transverse pre-stressing, longitudinal pre-stressing. But actually, the junction of the bridge wing and the main beam, there is a stitching reinforcement. The reinforcement will be subjected to cyclic loading. And actually then they are the end reinforcement bars in a system. The end regions are very dangerous under anchorage loading, anchorage bond. The anchorage bond behavior under cyclic loading is important. So actually it is a study actually we undertook, and also the bridge elements will be subjected to overloading. So actually the design loads are minimum load is 0, maximum load is 6 for the design of the bridge. But actually intentionally, after 1 lakh cycles of loading and unloading, the member is subjected to like the minimum says 0 and enhanced. So like 11 tons, instead of 6 tons, we applied 11 tons. Because this happened, for example, so in a highway between Hyderabad and Vijayawada, there's one bridge, long back, a carrier, okay, carrying a huge, iron cylinder, and whose weight was beyond the capacity of the bridge. So when actually nighttime when they tried to cross the bridge, the whole span got collapsed. So that is like overloading. when you apply the overloading, when the stress in the member exceeded, when the bond stress exceeded the reinforcement bar with the surrounding concrete, then this complete bond failure occurs. So it's a similar case actually here. When you design the bridge for, say, okay, maximum load and minimum load, say for 50 years, but actually it's fine, it will work. But when the load on the structural, okay, bridge deck exceeds whatever the maximum stress you prescribe, what happens? The bond stress increases. So then due to that, then it is a kind of accidental load. Due to this one, actually after 1,000 cycles of loading and load, maybe after few years, say, after few years, if you encounter an exceeding load, like an accidental load, then the bond stress, okay, bond gets deteriorated. Then that study we did, and even we found, so instead of 50 years, it failed at, say, about, say, 4 lakh. That is that due to the accidental loads, the bond failure occurred, and there actually the cement grout failed. So actually this one is characterized by the slip versus the number of cycles performed in the laboratory. So we found that up to 3.78 lakh, it was working fine. Due to overloading, then the failure occurred in the early stages. This is what the cyclic loading. Minimum stress will have bottom level, maximum stress level we have. So we have to apply. This way, the bridge will be subjected to minimum and maximum stresses, and we define the life of the bridge. So now that is one thing. Important thing here, when you relate this one with, say, cyclic loading. See, now this is your reinforcement bar embedded in concrete. It's fine for bond improvement. But actually, when you try to pull, what exactly happening? This is the rip, protrusion, deformation. In front of this one, the stress levels are so high. Suddenly the cross section is increased, okay, and the stress flow changed. Due to that, in front of the ring, okay, then exactly the cracks will form. We studied this one experimentally under cyclic loading in reinforced concrete beams subjected to cyclic loading with a defined maximum minimum stress. We found the micro cracks initiated started like this. It is the thing that is happening. If the stress levels are very low, if the bond stress is very low within the limit, and these cracks would have not formed. But when the bond stress exceeded, then this is the component normal to the inclination of this, and it is a horizontal component is a bond stress, and vertical component is a radial stress. So one of these components will be causing cracking. There actually, these are the transverse stresses causing the hoop stresses developed in concrete, okay, between the adjacent bars and even edge and the, okay, bottom cover. So that is causing like cracks in the cover. Anyway, this is important. So then the end reinforcement bars in segmental construction, we need to characterize, because this is something, a realistic information from the well-equipped laboratories, okay, with high precision, and after deleting the errors involved. This is the clear bond stress versus slip response that is fed into the computer or into the software, okay, for analyzing the system finite element software. This information is required for so many bond parameters. We would have not come across this, but these are the things required. Some softwares are taking this information also to understand the bond in the reinforcement bar with the surrounding concrete and the reinforcement characteristics and concrete characteristics, model them, model every phase involved, and then actually all realistic material characteristics are incorporated. Then when you use this software, you can, okay, come out with the solution exactly agreeable with the experimental finding. That's what actually you have to do. It's unless you have some planning, unless you have accuracy in the system, whatever may be done in the computer, you'll get some result, but that result cannot be acceptable. So you have to validate with the true experimental findings, and again, the efficient software should be developed. That is a lot of work is involved in that. And again, this is important thing. Now, okay, people are talking about precast system. The behavior of precast elements in direct tension, okay, tension combined with shear, okay, are many combinations. Whatever may be the case, this is a precast element. Okay, a reinforcement bar needs to be tested for its efficiency under cyclic loading. This is a setup required. So again, facilities required, and clear information needed, data needs to be generated. So then actually we tested this one again. After seeing the facilities available, we could have this setup. Then we tested them. Finally, the understanding of the precast elements with the different reinforcement detailing, with the different materials involved, we can find out. So we need to develop a material or precast element which will exhibit good ductility and good strength, but can avoiding sudden failures. So this process, actually, a lot of parameters are involved, varied. Then they tested in the laboratory. We found that many parameters like strength is improving, the capacity, then the reinforcement in the lateral direction improves the cracking resistance and ductility. Now, actually, again, as a part of this curriculum, okay, or as a part of the academic research, we also undertake studies on shear walls, which actually expose it to seismic loading. These shear walls exposed to seismic loading, and there were damages. Damages were clearly repaired with conventional approaches, and they were tested again for the cyclic loading to understand the characteristic. It is a typical shear wall, okay, tested for an organization in India. So there actually then the dimensions required by the organization accordingly we set, and there again squat walls and tall walls or slender wall. The squat walls are tested with good reinforcement detailing, exposed to cyclic loading or earthquake loading. So we found that this is the cyclic loading. Okay, so we applied the displacement amplitudes as per, okay, like a FEMA or say then there is a ASC or ACA standard. So whatever may be the case, then a real shear wall subjected to loads from the upper floors, that is a gravity load, that has to be applied, and the lateral forces acting to understand the cyclic behavior. This is that every cycle, every displacement magnitude, 2 cycles of loading, unloading were applied, and we continued up to like failure. We found that the retrofitting conventionally, okay, advantageous. So that means there will be good improvement, capacity slightly improved, and the ductility, but the soft failures were observed. And there was significant decrement in the stiffness. This is the response, okay? These are original things and repaired things. So there is a kind of more deformations, okay, slightly reducing. And another study, then the sandwiched beams were tested under fatigue loading. The fatigue loading, because not much information, all your code provisions, they very over conservative approach. The designs were highly conservative, highly over conservative, and the stress levels in steel may be very small. That is, they never reach the even permissible stress level. So therefore, there is a study required. So we need to take up the parameter study. When you take the cyclic loading, this is the type of failure. The bars will be snatched like this. Clear failure of the rebars under fatigue loading. Now, actually, again, is the manufacturing difference. The reinforcement bars used, maybe when the stress levels are slow, it's fine. But actually, when there is a manufacturing defect like this, the defect, as I mentioned, stress concentration, that led to the initiation of microcracking, then subsequent loading, unloading, more number of microcracks joined together to have macro cracking. So this way, stiffness decrement, suddenly there is a gradual decrease we never find, but it looks intact. But suddenly, when inside actually there's something happening, then this is a progressive failure. But one day you'll find complete collapse of the structure. That is the thing, in fatigue loading, all the structural systems, okay, we have to ensure, okay, things minimum life. Then anyway, deflection. Suddenly again, deflection, it was okay, almost like constant, but actually we never expected this will happen at this one, end of this one. Actually, the life was some okay, yeah, but it failed before due to the defects. Okay, these are all some of the things actually. So what actually we involved at IIT Madras. So then this is what actually I plan to exhibit during my technical presentation. Thanks for your patience, and thanks the chairman and the organizers for giving me the chance. Yeah.
Thank you, sir, for your excellent presentation covering
yes, sir, I'm done.
Wide topics. Sir, any questions? Very few questions we can take up now.
organizers.
Thank you, sir. That's a nice introduction. Sir, as of now, there are no questions from participant side, sir.
Harsha sir,
Yes, sir.
please give the co-host status to Dr. Bashar sir here.
Yes, sir. Okay, sir.
Sir, Aparagaru, is it better to have mechanical anchorages, sir, instead of ribbed bars?
Yeah, but the behavior is almost same. Even mechanical anchors also they have the like the transfer of forces through adhesion, then friction, then mechanical interlocking. So even mechanical anchors also they will have some deformations. So then depending upon they want to achieve good bond strength, then they have deeper projections. So that is actually similar to the reinforcement bars even available in the market. There are some rebars also that are producing like a diagonal pattern, then discontinuous pattern. Okay, some bars actually they are producing, but it's a similar behavior is there. But then still there is a problem.
Sir, we also have Venkatraman, sir, one of our co-chair also with us. And I welcome, sir, Venkatraman, sir. You also, sir. Sir, the next.
Thank you.
Yes, sir. The next session is going to be commenced by Bashar, sir.
Okay, so
yeah. Sir,
Thank you very much. But can I share my slides, please?
Sir, 1 second, sir. Let me
welcome you, sir. Dr.
Thank
Bashar
you.
Mohammed, sir. Welcome
Yes,
you.
Thank you. Thank you.
Hello.
Sir,
Sir, voice breaking, sir. Sir, voice breakout, sir.
Sir,
my voice, sir.
No, it's audible, sir. It's audible.
Okay, I think some
Can
disturbance from
you,
my
Dr. Kumar, can you allow me to share my slides, please?
Just a minute, sir. Just a minute. We will introduce your. You will introduce, sir. First, after that, you can share.
Okay, thank you.
Okay, thank you, doctor.
I request our chair Srinivas, sir. Please introduce Bashar Mohammed, sir.
One minute, sir.
Yes, sir.
So I am pleased to introduce Dr. Bashar S. Mohammed, C. Engineer, FICE. He is an associate professor in the Department of Civil and Environmental Engineering, University of Technology, Petronas, Malaysia. Engineer Dr. Bashar has over 25 years of professional structural engineering experience as educator, researcher, and structural engineer in various parts of the world. He has published more than 200 peer-reviewed research papers. Dr. Bashar is the author of textbook entitled Design of Reinforced Concrete Elements to Eurocode 2, which has been received the National Book Award Vayasan Pembangwan Baku Nagara Serba. I'm sorry for my pronunciation.
No problem. No problem.
Serba 2018, and he is also the recipient of scholarship of teaching and learning grant entitled The Impact of Higher Level Thinking on Students, Achievement Towards Reinforced Concrete Design course. Dr. Bashar is currently the chair of Civil and Environmental Engineering Department, U2P, and also the president of My Geopolymer Society, Malaysia. I welcome you, sir.
Thank you very much.
Right.
Thank you.
Yes, sir. Welcome to our international conference on advances in civil engineering, sir. Thank you for being with us, sir.
Welcome you, Dr. Bashar. Thank you.
Thank you, Dr. Kumar. Thank you. But can you give me the to share my slides?
Yes, Virendra,
Yes, sir.
please.
I am
Yes, sir. Yes, sir.
Sir, I have given just now, sir.
Okay, can you see my slides?
Yes, sir. Yes, sir. You please go ahead. Make it full screen, sir. Right.
Yes. Okay. First of all, thanks. I would like to thank the organizing committee of ACE 2021 for inviting me to share my knowledge on rubbercrete with other researchers. And also, I wish everyone in good health during this pandemic of COVID-19. I am Basharas Muhammad, Associate Professor in Civil and Environmental Engineering Department, University Technology Petronas, Malaysia. And my presentation is about the trends and practical application in recent academic research on concrete containing chrome rubber. So this is you see the slides when we put the chrome rubber keywords in Scopus database. So far we have about 2,823 documents. And you see that the trend is increasing from, you see in 2012 is only 96 paper published, but when you come to 2020 is about 402 paper has been published. And this one shows the importance of the rubbercrete, and I will explain what does it mean, the rubbercrete. And here myself, I am second publisher here with about 50 papers with the keywords of chrome rubber. So these are the tires. The tires in America, the pronunciation is the same pronunciation, but only maybe the spelling is different between America and UK. So the composition of the tire, the scrap tire usually, is about 83% is rubber, 12% is steel, and 5% is textile fabrics. So according to Ohio administrative code, defines a scrap tire as a type of solid waste and includes any unwanted or discarded tire regardless of size that has been removed from its original use. So there are three types usually of the scrap tires. It's a passenger car tires, the truck tires, and off-the-road tires. So what's the environmental problem associated with the waste tires? Tires are bulky, and 75% of the space of the tire occupies is void. That lead to the landfilling of scrap tires has several difficulties because the scrap tires require the largest space in the landfill. And scrap tires usually non-biodegradable waste due to the material, because of the material enter in the composition of the tires itself. And usually these scrap tires, when catching fire, is quite difficult to extinguish the fire. It's quite difficult to put off the fire. So they will release a huge toxic fume to the environment, large amount of CO2. And also it will release some oils which can penetrate through the soil and reach to the groundwater, and at the end contaminate the waterways. And improperly discarded tires are ideal breeding ground for disease carrying mosquitoes and rodents due to the shape of the tires. Waste tires management in Malaysia. Actually, we have 5 types of this kind of management. The first one is a physical reuse. The second one is open burning. The third one, landfills. The fourth one, illegal dumping or stockpiling. And the last one is a low-cost supplementary fuel. So this is just example of the physical reuse. We use them as erosion control, and this one is quite dangerous because the oil and the toxic material ooze from these tires will penetrate the soil and contaminate the groundwater and also reach to the waterways. This is the second one, open fire. This open fire, intentional fire, where when these tires catching fire, so they release a huge amount of the CO2 to the environment and cause a haze. Also, sorry, I just, yeah. And also, when we threw the scrap tires to the landfills, also there is intentional or unintentional can be catch in fire. And this is a waste tire in a landfill. So this is how they threw the waste tire or the scrap tire. This is another landfill. These pictures are from the landfill. Illegal dumping create aesthetic problem. I saw a breeding ground for pests and vermin, leaching of organic chemicals from tires in stockpiled area, causes fire hazard and causes risk to cancer. This is illegal dumping of tire. It's just show one picture from one of the villages. This also the dealer shop. This one also is considered as scrap tires. Also the chemical and the toxic material can be used from the tire, the way how they store it. This one is one of the just illegal dumping the tires. I can show in the picture from one of the villages. Low-cost supplementary fuels. This is according to a study on the scrap tires management for Peninsula Malaysia, released by National Solid Waste Management Department, Ministry of Housing and Local Government. It's stated that the cement industry uses scrap tires as a low-cost supplementary fuel due to their high calorific values. And again, it will release a huge amount of CO2 to the environment. So what is the solution? One of the alternative waste management option to solve the waste tire problem is recycling the waste tires for a useful use. The best solution is by utilizing a crumb rubber into the concrete production. So reduce these tires to the small particles, we call it crumb rubber, and we use them in the concrete. But why in the concrete? Because the annual global production of concrete is about 3,820 billion cubic meter a year, according to the Cement Association of Canada, and this is next to the consumption of water per capita. So the process here to reduce these scrap tires to the crumb rubber, start by shredding the tire, then a primary granulation process where reduce them to the chips, and then to the secondary process where reduce them to the smaller chips. Then the last one is cracking or grinding rolling mills where it produce the crumb rubber, and in the process there is a magnetic to remove all the steel from the crumb rubber. So the first intellectual property, if you search in Google, you find it registered under Prof. Hanzu, and the title of this intellectual property, crumb rubber Portland cement concrete, registered in 1994. At the time, Prof. Hanzu was working with the Department of Civil and Environmental Engineering, Arizona State University. So he's the pioneer in this area, and he's the one who initiated this research on the using crumb rubber in the concrete. So the benefit of crumb rubber, of rubbercrete, when we add the crumb rubber as a partial replacement to the fine aggregate or to the sand, so the final product, we call it crumb rubber. So this, inclusion of this crumb rubber in this concrete will lead to many benefits of the concrete. So the concrete has become lighter in weight, high air content, ductile, improve the slump, impact resistance. So this one, when we talked just now about the column beam joints due to the cycling load, this is a very good material to be used in this area. Better sound absorption with higher noise reduction, soundproof, better electricity resistivity. But what's the problem with that? When we add the chrome rubber to the scrap tire, due to the hydrophobic nature of the chrome rubber, repel water and entrap air on its surface. So the interfacial transition zone between the hardened cement matrix and the chrome rubber particles is become like there is a tiny voids or become thick. So during the load application, it will cause internal stresses. So these stresses cause cracks, so will lead to the premature failure of the rubbercrete. So, okay, this is just part of our contribution to this one. Strength reduction factor of the some of the paper we published on this one after we studied this rubbercrete. So, strength reduction factor for structural rubbercrete. Okay, when we add the chrome rubber to the concrete, definitely we call it rubbercrete, but we can't use the available standards to design the mix of this new concrete because due to the material. So we have to develop a new procedure or method to design the mix of this rubbercrete. So we introduced this what we call it reduction factors. So the reduction factors, we find the reduction factors, then we use the normal method in design of the concrete mix using ACI or a British code. Then after that, we use the reduction factor times the target strength. Then we'll find the real target strength of the rubbercrete. So this one, we done it for the compressive strength, the flexural strength, splitting tensile strength. So we provide all the data is available in the paper, and all these reduction factors, how to find the reduction factors is available in the paper. If you like to design the mix of the rubbercrete, you can refer to this paper and you find all the reduction factors there. This is just show that the chrome rubber itself is the size of the chrome rubber is somehow similar to the size of the fine aggregate. That's why you can use it as a replacement to the fine aggregate in the concrete. And this one, some of the data on the low slump, you see the slump of the chrome rubber of the rubbercrete actually improves. So you have, if you have a problem in the slump of the concrete, you can use some amount of the chrome rubber replacement, like 5%, to improve the slump without increasing the water ratio, because the water ratio lead to the decreasing of the strength. This one I just skip it. And then another paper is the evaluation of rubber-based ultrasound pulse velocity and rebound hammer test. So when we develop it, we want to know if we are using the non-destructive test, how this non-destructive test can be used for this rubbercrete, because usually for the concrete, we know it, the code developed already, but for this new material, so we did test it, and then we find all the real curves for it together with the formula. So if we test the or we conduct the non-destructive testing on the rubbercrete, so we can use these curves to find the real values, and also these curves also available in our publications online. If you like, also I can send it to you. You just email me. And the failure mode is very interesting. So you see the failure mode when we don't use the chrome rubber, 0%, you see the type of the failure mode. But when you increase the chrome rubber up to 30%, you see this is the failure mode. It's intact one. So it's a very good in area prone to earthquake or cycling loading. Also, this one to show that the modulus elasticity, if we are using the formula, whatever available in ACI code, the British code, Turkish code, so this formula cannot be used really for the, what you call it, the rubbercrete. That's why we create the new formula to be used to find the target modulus elasticity. And also, there is a big question, like how this concrete rubbercrete behave under the elevated temperatures. So, because some people claim catch on fire, what actually is we're not catching fire. We tested up to 900 centigrade, where we see that, yes, the compressive strength decreased, but there is no a huge amount of the CO2 or the fume or the smoke in the after we burn it, because the amount we use is a small one and encapsulated inside the concrete. Then also we developed, this is the crumb rubber hollow concrete block. So this is the block. This block we have tested. We find it is a very interesting block. There are so many good improved physical properties, such as a soundproof, such as the low thermal conductivity, high electrical resistivity, and so on. So it's a load bearing. It can be used a load bearing brick, and also the thermal conductivity you see decrease, so it will lead to the save of the energy. And also you see that the noise reduction increase, and the sound transmission decrease. So this block can be used in the schools, hospitals, seminar rooms, to prevent the sound from pass from one place to another. So and also to reduce the echo. So this one improved the quality of the building, hotels, especially the hotels, between the hotel rooms and so on. This is the electrical resistivity increase. And also we studied the rubberized concrete interlocking masonry wall. This interlocking masonry wall, we use a semi-automatic machine. This machine can produce 600 pieces per hour. So it will be interlocking, and we study all the structural behavior and of the wall and the prism and the brick, unit brick itself. And we have published a book. I will show you the book later. Is available online. So if you like to know more about the properties of this brick and how to use it, it's actually is a very good one and can improve the life of the people. And also we develop using a geopolymer concrete. Geopolymer concrete also we are used to develop this one. It's usually geopolymer concrete takes a long time to cure and harden. So this one actually even the brick, interlocking a brick using the rubbercrete, this one made of dry mix. Dry mix then meaning we put it in the machine, we press it under the pressure, then it will have its shape. So no need to put it in the mold for 24 hours, whatever. Similar thing for geopolymer concrete. Geopolymer concrete, there is no cement at all. We are using different material to bond the material and the material of rubbercrete inside. And also we did study the response service model for self-compacting hybrid fiber reinforced concrete. This one published by Dr. Kumar. Dr. Kumar is here with us just now. So this one, why we initiated this kind of research? Because even the steel tire wire from the scrap tire, when we remove it, we want to see whether we can replace the BVA, because the BVA is a very expensive. So it's good for us to find a better replacement recycling material to reduce the cost of the ECC. And also we did a study, we use it in the composite slab. The composite slab, when we use the topping concrete usually is a very rigid, and the sheeting, steel sheeting is a very ductile. So due to incompatibility, under a very low load, it will be break. So, but when we are using the rubbercrete, because the rubbercrete is a ductile, so it has some flexural deformation without breaking. So when we use it as a topping material for the steel sheet in the composite slab, so it will have a better enhance the capacity, load carrying capacity of the composite slab. And also we did a study. Now, if you want to use it, you say, okay, I don't want to use because it will reduce the strength. I want a high strength of this rubbercrete. So we did use a nanosilica. The nanosilica, what it did, because there are two effect of the nanosilica chemical, the CaOH, and CaOH by 2, and they produce the gel, which is responsible about the strength, and also it can fill all the nano voids inside the structure of the microstructure of the rubbercrete. So densify the ITZ between the hardened cement base and the crumb rubber, and also increase the compressive strength. Sorry. This is the interfacial transition zone between the crumb rubber concrete and the hardened cement paste. So this one, when we are using the nanosilica, reduce the thickness of the ITZ. I just passed through this one. It's also refined the pore structure inside the rubbercrete as well, and increase the thermal conductivity. Sorry. Sorry. Because I have to leave for my my vaccination, so they are keeping calling me. Okay, I will finish it within 1 minute. So this is the ITZ between the crown rubber and the hardened cement paste. So when we are using the nanosilica, it will thickening. It will make it crush it, the ITZ. So it will lead to the improve the what you call it, the compressive strength. This is the book I mentioned just now. And I want to also acknowledge my student who work on this project, Miss Najwa, Mr. Jackson, or Dr. Musa, and this is our friend here with us, Dr. Komar. So he done on this one a lot of work, and Dr. Amin, Mr. Robin, Dr. Ishaka, Shafika Binti Shahrul, Miss Noor Izzati. And then we have so many awards for this one from the one, but this is what I want to mention is already we received the IB for it, intellectual property in Malaysia. And also we have another few products. So this is the one also we call it theoretical block. The trademark is registered in Malaysia. So if you like to have more information, you are welcome to call me anytime you like. Thank you very much.
Thank you, Prof, for the nice presentations.
I'm sorry, I have to leave for my vaccination. I'm sorry.
Yeah, we understand, sir.
I'm sorry, because they just called me last minute, so I couldn't arrange for it.
Yes, sir. Thank you, sir. Thank you.
Thank you very much. So
If
any
few questions or you are leaving? No time.
I have to leave now for my vaccination because they keep calling me.
Participants may pose questions through chat box or through
Yes.
email.
Through email.
Yes, sir. Yes.
Dr. Kumar, you can share my email with them.
Yes, sir. I can share.
Thank you very much. Thank you.
Thank you, Prof. Thank you for sharing your time.
Bye.
Thank you.
Thank you very much. Thank you.
Thank you, sir.
So now, Virendra Kumar Garu, can we go ahead with the participants' presentation?
Yes, sir.
6 papers.
Yes, sir. Just I will call upon Mr. Aniket Patkar. Please raise your hand, Aniket Patkar.
Aniket Garu, you may I know your name or something that which you have logged